Welcome back to PPT, and now we are going to learn about compound operators in relational algebra. We are going to start with intersection. So yeah, let's start with intersection. So relational algebra நாங்கள் வந்து பேசிக்கான சில ஆப்ரேஷன்ஸ் பார்த்துருந்தோம். Yeah, அதில் வந்து ஆரம்பிக்கும் போது we had selection, we had projection, we had union, we had set difference, we also had postulate. Okay, and we also learned about renaming operations. Okay, other than this basic operations, okay, other than this basic operations, we also have compound operations. Okay, we have compound operations. And the special part about compound operations is when you were studying about logic gates, okay, when you were studying about logic gates, okay, we had basic logic gates. Obviously, we had some basic logic gates. For example, we had and, we had or, and we also had not. And once you combine these different basic logic gates, you came up with combinational logic gates. Okay, for example, and not gave us NAND. Or and not gave us NOR. This is how we came up with compound logic gates. Okay. Similarly, we also have compound operations in relational algebra. Okay. The basic ones are intersection, join, and we also have some types of join that we have to focus on. Other than these two, we also have division. Okay. So these are the ones that we are going to focus. In this video, we are going to learn about intersection. Okay. Intersection is not a new term for you based on your past experiences and all. We normally know what intersection is. Okay. In set theory, we have learned that if we have two sets, okay, let's say for example, if we have two sets and let's name those sets A and B. Let's name those sets A and B. Intersection is the common part for these two sets. Intersection is the common part for these two sets. And we give a notation called A intersection B to mention this intersection between sets A and B. Similarly, in relational algebra, we talk about two relations. Okay, when we are talking about two relations, okay, let's say there is a relation one and there is relation two. Well, intersection returns us with the tuples that are present in both relations. So, what's the definition for intersection? What's the definition for intersection? Returns a relation that contains only those tuples that exist in both input relations. Intersection, this operation returns us a relational instance, returns us a relational instance or relation, returns us a relation that contains only those tuples present in both input relations. So the syntax is relation 1 intersection relation 2. This is the syntax that we use. Tally enough. Yeah, this is not that hard. So let's now focus on how we can come up with an equation for intersection by using only relational algebra. To understand that, first of all, we'll talk about how intersection works in set theory. In set theory, we have a famous equation, famous relationship that we use in multiple times, even we use that in probability also. Okay, and that famous relationship is A union B is equals to A plus B minus A intersection B. By using this, we derive uh, an equation for A intersection B, which will be A union B minus A plus B. But here, in this case, plus and minus are actually arithmetic operators. They are arithmetic operators. They are arithmetic operators, which means we can't actually use them directly in relational algebra. This means we have to come up with a clever way to understand and create a useful way to derive an equation just using relational algebraic operations. So I'm gonna teach it to you step by step. Here, let's start with sets. Yeah, that's easy. Yeah, that's easy. We'll start with sets. We have two sets, and let's name those sets R and S. The first step will be, okay, the first step will be we have to isolate this area. இல்லையா? அதுதானே எங்களுக்கு இருக்க target. That's the target for us. We have to isolate that part. That's the $1,000,000 question here. So, what can we do here? First of all, we will just isolate R. We will just isolate R. Okay. If you consider R has two parts. That is, this one is R only. This has only R without S, without S element. This part has R elements are there, but they are also common for S elements. If I can find this specific area, if I can extract this specific area using relational algebraic operations, don't you think don't you think I can use set difference to retrieve this specific area? By set differencing, let's say this is R only without S, right? This is R only without S. And if I use set difference between R and R only without S, what will be the output? Definitely, the output will be R intersection S. Why? This will be remaining. That's the idea I'm going to use here. First of all, I'm going to find out what I can do here. So, this one is R but not S. That's the idea. R but not S. That's why we are going to use R minus S. Now, this leaves us with what? Only this specific area of R. Now, if I find the set difference between R and R set difference S, I can actually come up with R intersection S. Second step, okay, in the second step, I'm going to remove this area of elements from R. This area of elements. So R minus S. I hope you can understand. Okay, I hope you can understand. If you can't understand, please go back and watch. Therefore, it will be really easy. Okay, this is really easy to understand. So, what's happening here? What is happening here? We had two sets. We had two sets, R and S. Okay, we had two sets, R, and S. To isolate this specific area by only using relational algebra, the first step I did was I only took out this specific area, which is R but not S. So for that, I used set difference operation, which was R set difference S. After that, I removed this area from R to isolate R intersection S. So that's how we came up with R intersection S is equals to R set difference R set difference S. So this is how we can come up with the compound operation intersection by using just inter set differences. Okay, you can come up with this in another way. R intersection S is equals to S minus S set difference R. The set difference between S and R can be used to find the R intersection S. These are the two ways of finding the R intersection S. This can be used similarly. Yeah, if we have two relations R1 and R2, we can say R1 intersection R2 will be equals to R1 set difference R2, or you can say R2 set difference R1. Okay. Both ways are possible. Since we are using set difference, to find out intersection, the relations we are using must be union compatible. They must be also union compatible. That is also very important. Keep that in mind. They must be also union compatible, or else we can't apply set difference, which means we can't apply intersection. Okay. Now I'll explain it with an example. What happens here? See, we have A, B attributes in the relation R. Okay. And in relation S, also we have attributes A and B, but the tuples are a little bit different. In R1, we have 1x, 2y, 3z. And in R, we have 1x, 2y, 3z. And in relation S, we have 2y, 3z, and 4w. If I run the intersection operation on relation R and relation S, the output will be A, B, 2y, and 3z. This will be the output since these two tuples are present in both the relation. Only these two tuples are present in both the relation. This can be also understood. This can also be understood by breaking down these into simpler steps. The first step will be R minus R set differences. You can see we already learned about set difference in the earlier videos. So R minus R set differences. So what are the tuples in R that are not present in S? Well, only 1x is present in R that is not present in S. Therefore, this will be the output for R set difference S. Okay. And now the second step, we can't stop there. We have to do the second step. The second step is R set difference, whole thing parenthesis, R set differences. And this had the tuples 1x, yeah, AB 1x. This had this. R has AB 1x, 2y, 3z. Now we can apply set difference again. In that case, what does R has that is not present in R set differences? Well, 2y and 3z are there. So the output will be these two tuples. This is how we come up with intersection operation in relational algebra. Alright, it and that's all we should know about intersection in relational algebra.
Thank you for watching this in-depth guide on intersection in relational algebra. If you enjoyed the video, please like the video to show your support, share it with your friends and classmates, subscribe to the channel and turn on notifications for updates on the Relational Algebra series and other ICT lessons. I'll see you in the next video. Until then, keep learning and stay curious. Bye-bye.